following integral we're going to solve by integration by partial fractions. We have dx on top and x times x plus 3 squared on bottom. So we're going to start by taking the integrand and breaking it into three parts. The first being a over x plus b over x plus 3. Now this is a repeated linear term, meaning x is to the power of 1, so it's a linear term, and it's repeated in that it happens twice. When we're using partial fractions then, we have to include all powers, or all possible powers, meaning because this is x squared, we need x to the power x plus 3 to the power of 1 and x plus 3 all squared. If this was x plus 3 to the power of 5, we'd need to the power of 1, to the power of 2, 3, 4, and 5. All possible powers. From here, we do it just like we did the previous example. So we're going to multiply both sides by the denominator, leaving 1 on the left. A times x plus 3 all squared plus b times x plus 3 plus c times x. Now we're going to choose our x values, choosing them to eliminate some of our terms. So we'll start with x equals 0. That'll cause this term and this term to disappear, so we end up with 1 equal to a times 3 squared, 0 plus 3 is 3, plus b times 0 plus c times 0 are gone, meaning a equals 1 over 9. So there's our a value. Now we're going to let x equal negative 3, and what that'll do is cause this term and this term to disappear, because this will be 0 and this will be 0, and we'll be able to solve for c. So we end up with 1 equal to a times 0 plus b times negative 3 times 0 plus c times negative 3, meaning c equals negative 1 over 3. Now we have a and we have c, but we have no other way to make these two terms cancel to find b. So what we do is we choose any value of x. Let's say x equals 1. Since this is true for all values of x, it doesn't matter what we choose. We're going to put in 1. We know a, we know c, and we can use that then to find the result for b. So we're going to end up with 1 equals 16 times a, 1 plus 3 is 4 squared, 16, plus b times 1 times 4, so 4b, plus c, 1c. We know a and c, so 1 equals 16 over 9 by putting in a, plus 4b, plus c, which is negative 1 over 3. That's 4b. Collect all the terms on the left, so 1 minus 16 over 9 plus 1 over 3 equals 4b. 1 minus 16 over 9 is negative 7 over 9 plus 3 over 9 is negative 4 over 9. Let's work through that again. 1 is 9 over 9, so 9 minus 16 is negative 7, plus 3 is negative 4, and common denominator is 9, over 4b. Divide both sides by 4, and we find that b equals negative 1 over 9. So there's a, b, and c. Now we get to integrate each of these parts. So we're going to take our integral now, and that's going to equal the integral of the first, which is going to be 1 over 9 over x dx, plus the integral of the second, so b is negative 1 over 9 over x plus 3 dx, plus the integral of the last, which is negative 1 over 3 over x plus 3 all squared dx. And we've gotten three functions, or three integrals, that we can integrate relatively easily. This is 1 over 9 ln of x. This is minus 1 over 9 ln of x plus 3. I guess we should put the absolute value there to be accurate. Minus 1 over 3 times, now this is to the power of 2, which means it's x plus 3 to the power of minus 1 over minus 1 plus a constant here, giving us, if we simplify it fully, 1 over 9, subtraction of 2 logs is the same as the division, so that's x over x plus 3, plus minus minus 1 over 3 times x plus 3. So there's the fully simplified form of the integral.